Hello friends, welcome to Data Nebula. My name is Venkatramana. So today we are going to see very common data engineering question. This question is related to Spark. Okay, so many of the interviewers, right, they want to check how you are analyzing the data and how you are giving the Spark configurations. Okay, so many of the candidates doesn't know how to give the Spark configuration. They know how to code, but they don't know how to configure the sparse submit command. So for that, I came up with one example, okay, with a simple calculation. This is basic calculations only, basic math only. Yeah, let's get into it. Okay. For suppose we have a file size of 100 GB. Okay. In our Spark application, we are doing some transformation, then we are doing some aggregation. Okay. Just assume like that. So for this, okay, now we'll calculate how much resources we require, okay, to process this data completely parallel. Okay, first step is we need to calculate how many partitions it will create when it reads, okay, in Spark. For that, the calculation is like this. Okay, number of partitions is equal to file size in MB divided by partition size. So for suppose for us, we have 100 GB of data, so that means file size in MB is 100 into 1024. That will convert in MB. Okay. So ideal case partition size will be 256 MB. Earlier in initial days, it was 126 MB. Now most of the file systems support 256 MB. Okay. So now it becomes if we calculate this, right. If I divided this value with this, okay, it will become 400. Okay, so this will create this. I mean, when Spark reads this much 100 GB of data, okay, it will create 400 partitions. That means, we need those many cores. Okay, I mean to execute. I mean to process entire data completely parallelly. Okay, we need 400 cores. Okay, now based on this course, okay, we come to know how many cores we require now. What we'll do now, based on this, we'll calculate how many executors we require for processing our data. Okay. Now for that, okay, basic rule is, okay, recommended cores for executors is 3 to 5. Why? Because for suppose if you give less cores, right, we are not going to utilize Spark properly. And also if you give more cores for each executor, okay, that will create more parallelism, and it may also cause some performance issue. That's why ideal case we need to choose the number of cores per each executor is 3 to 5. So for our case, I just chosen 4. Okay, so that our calculations also will be easy, and also that is a ideal case also. I mean, I chosen in between 3 to 5, right? So that's why. So based on this, okay, the number of executors is, okay, we have total cores, right? We have 400 cores, and we have decided cores 4 cores will allocate for each executor. That means 400 divided by 4, that means 100. I mean, we need 100 executors, each assigning 4 cores. That means we are utilizing all our cores, and we have decided we need 100 cores to process our 100 GB of data completely in parallel. Now now we are done with how many cores we require, and we are done with how many executors we require. Now we need to know how much memory we require for each executor. Okay, normally people used to give 8 to 16 GB. Okay, for our use case, I'll choose 16 GB. Okay, 16 GB for each executor. That means we have 100 executors, that means we need 1600 GB total. That means 1.6 TB. Okay, now I'm just repeating once again. Okay, we what we have done is we need for processing 100 GB of data, okay, we need 400 cores. Based on that one, we have computed executors required. That is 100. Each executor we are assigning 4 cores each, and also executor memory we have decided 16 GB. That means we require total memory of approximately 1.6 TB. This calculation, this is just basic calculation only. Okay, based on the data, we just computed these things. But it depends on your use case also. You may need to just adjust these numbers according to your use case. Yeah, that's it, guys. Thank you so much.